Jim borrowed $8,000 at 6.5% compounded monthly and agreed to repay the loan in equal quarterly payments over the course of 4 years. What we'd like to do is try to figure out how much of the fifth payment is going to be interest and how much will be the principal part of the 11th payment. Since we're not given the payment size here, we are going to have to do a little bit of work with our calculator in order to determine that. To keep things simple here, let's take our calculator to be in end mode. We know that Jim has borrowed $8,000, so we'll take that as a positive $8,000 for our present value. We're going to pay off this loan, so the future value should end up being 0. We have interest that is 6.5% compounding monthly. We've agreed to make quarterly payments, and we know that those quarterly payments happen over the span of 4 years. So n should be equal to 16. Knowing this, we should be able to pull up the calculator and start programming these numbers in to try to determine the equal-sized payment that we need. So here, heading into the submenu, just making sure that my PY and CY are programmed in correctly. Let's get 8,000 in as our principal amount, 0 in as our future value. And hopefully when we compute the payments, they come out to be negative. So I'm just going to write the payment size down up here close to the top so that we have that as we start to work through part A and part B. But we do see here that the equal size payments that we are going to be giving back to the bank, let's say, to pay off this loan are of size $572.25. As we start to move into solving part A and part B, we are probably going to need I2 here as well in order to work with our amortization table. So let's go ahead and start calculating I2. Let's take 1 plus our current rate, which is 0.065. We need to divide that by 12. And then we're going to raise that to the power of 12 over 4, which is 3. And subtract 1. Since we are probably going to need to use this a couple of times, let's go ahead and store I2 inside of number 9 so that we can recall it later. I've gone ahead and I've started to set up our amortization table with the following 5 headings. We're going to look at N, the payment size, the amount of interest that we have at that particular time step, the amount of principal we have at that particular time step, and then we can look at the balance if we need it as well. We can start to fill in some of the numbers that we know, including the equal-sized payment at steps 5 and steps 11. Notice that at step 4, I don't really need the information about the payment, the interest, or the principal. I'm just curious about what the balance is at the end of step 4 and at the end of step 10. So we will have to use our calculator to go and find these two particular balances. And the easiest way to do that is to update the information that's in our calculator. So let's give the calculator that the payment size is $572.25. Let's ensure that we put this in as a negative payment. And we're also going to update that we're curious about what's happening when n is equal to 4. And specifically, we want to know what the future balance is at that particular time step. And here the calculator gives us $6,190.06. Let's repeat this procedure using n is equal to 10 and asking the calculator to give us the future balance at time step 10. And we get $3,245.37. Now we have enough information to start filling in rows 5 and 11. Let's take our $6,190.06. We're going to multiply this by I2, our stored interest rate, and see what we get. So the interest at step 5 is going to be 101.13. Okay, so here is the answer to part A. Similarly, we can take our $3,245.37. We can multiply this by our stored interest rate, I2, and get the amount of interest we need to pay at time step 11. This is $53.02. If we know this is the amount of interest we pay at time step 11, let's take our payment of $572.25, and if we subtract this interest amount, we should get the principal amount at this particular time step. So $519.23. And so this should be the answer that we are looking for part B of this problem.